Hello everyone, welcome to Connection Wednesdays, our regular online training focused on a connection of design of steel connections in IDEA StatiCa software. My name is Jana. I'm a product engineer at IDEA StatiCa, and next to my desk there's Adam. And we are both product engineers located in Brno in Czech Republic. Before we start, as always, we are really happy to answer your questions. Nevertheless, you are muted and you can send us your questions via the questions panel in GoToWebinar application. We will try to answer them during the webinar, and if we don't have enough time to answer them, we will send you an email after the webinar. So what we'll see today is an interesting customer project. Today we will import a suspension joint from Advanced Steel. So you will see how the BIM link between Advanced Steel 2019 and IDEA StatiCa Connection works. And this will be the Adam's part of the webinar. And then in the last few minutes, we will have a look at one of our HelpDesk tickets from the customers, and we will have a look at how to weld the end of a rounded box member. So now Adam will talk a little bit about the first project.
Yes. Hello to everyone again. I'll talk about the BIM link from Advanced Steel to IDEA StatiCa, which works pretty well, except some, let's say, customer or user misunderstanding, and that's what we will discuss today. So what about the BIM links from IDEA StatiCa? Except for Advanced Steel, we have a couple of softwares connected through this link. For the CAD softwares, for drawing, it's Tekla and Advanced Steel. And for the structure softwares, it's a couple of others like SAP 2000, Robot, Revit, SIA, StatPro, Blueball, and so on. So those are the official BIM links that we support, we maintain, we code, and we release for you to be used. Next to that, for, let's say, not that common softwares or regionally used softwares, only in some countries, let's say, we have another option. We don't support all of them, with the BIM links, but you or somebody from the software that you would like to link to can link it, actually create the BIM link themselves. And for that, we provide you a complete documentation and a platform that we call IDEA Open Model. You can find it on a GitHub or on our webpage in the Resource Center. And that's an option how to link any structure software, for example, to IDEA StatiCa. Now, about let's say, common mistakes or the misunderstanding using the BIM link from the CAD softwares, Tekla and Advanced Steel. There's a couple. We've got a time to time or quite often questions from our customers on our help desk. Well, since this doesn't work and that doesn't work, and how to do that. And so I collected probably the mostly common mistake to say, and those are the connection is not well designed in general. There are some welds missing in the drawing. There are wrong settings for bolts, for example. There are some user-defined materials that are somehow complicated or wrongly set as well. or the whole input of the joint or the connection in advanced steel is somehow corrupted or not very well set. So since this is not well done in advanced steel, it loads in the same state into IDEA StatiCa, of course. And there is one thing that we can profit from, and that is that we can actually do the design in IDEA StatiCa itself directly, and then we can export the design to 3D DVG in our online viewer and get it back to the drawing software, the CAD software. So I will now jump, I'll take the presenter, turn off the webcam, not to disturb you anymore, and now you should see my screen showing the Advanced Steel 2019 and the model of the joint that we got from France. It's a part of a interesting project, but unfortunately we just got a just this part of it, and this old drawing of that. We've been not provided with the whole thing, but this is still useful and a perfect example for this topic. So there's the connection, obviously, it's somehow designed. On the first look, there's probably something missing as well. So let's see if I now switch to wireframe, open the code check manager by typing the command con UI. And here I will select the code which I would like to work with. So I'll pick up Eurocode. Now I'll go for the node of the joint, select each member, these rods as well, and select the items of the joint, all the blades, welds, and bolts. Now a couple of seconds for IDEA to open. And 2 more seconds. There we go. So that was quite easy to get it here, but as we see, this is not what we expected. I'll turn off the member sign so we get where see. There's obviously something wrong. So what's that? Those rods are shifted. They are missing. The connection of those tubes is missing. These plates are not welded to the tube. As I switch to transparent view, there is no weld. So let's fix that. I'll show you a couple of tricks on the way. First thing I would do, if I go step by step, of course, let's see on the members. This looks okay. Continuous member, the tube that is the bearing member with supports. Fine. And for the others, I know those are rods or wind bracing that works only for tension force and shear forces. So that's why we have to switch here to the model type tension shear only. So I'll do that for the tubes and for the rods as well. Those are a bit hiding here below the gusset plates, but nevertheless, and those are already set for the tension shear only. That's what we loaded from Advanced Steel. So those were actually well set, except that they are not connected. But we'll fix that. So next, I will import some load effects, those that we got from the structure model. So I have them exported in the Excel sheet, just one set as a demonstration. So I will copy those forces, click import, paste it here, okay, and I got all the forces in place. You can check here that those are in equilibrium, of course, since those are the nodal forces from the structure model. Well, I will just turn it off right now so we can see the joint. And we'll now continue with the design to fix that and finish that. So I will start adding operations. First, I will weld or add welds, the missing welds between the gusset plates and the main tube. So the weld operation, and here I'm welding this plate to this tube. Switch to transparent to see which edge is the connecting one. You can see here it's number 2. So I've got the weld in position. Just switch to double fillet weld and 3 millimeters of thickness. Okay, now I'm copying this to the lower plate as well. Again, I'll just pick the edge number, which is 11 in this case. So this is somehow tricky. You can get a bit lost. We have to make sure that this number is well set. Otherwise, the model will not calculate or will calculate in a wrong way. So this is one important thing, always to check this edge number. All right, next I will continue with fixing these rods. So I will have to add another gusset plate or gusset operation. I will start with this first rod on the right side, and I'm not connecting to new plate, but the existing plate that is already drawn or designed in advanced steel. So that's this one, and I will select the number. Now it's looking good, and I will just shift this a little bit more so it's ended like here, and of course I will switch to butt weld. So this looks good, and of course I will not repeat it again and again. I'll just use the copy function and change the assigned member and plate, and here I will change the offset to, or the gap to 10 millimeters, because this is again set to another origin from the advanced steel, so we have to play with this a little bit. Another copy. Now this one, and the plate is this one. Here it's 55 again, and another copy. This member and this plate, and again this is 10. All right, this is connected, and the last thing, those tubes, and I will use a nice trick, a little tip for you, a U-shaped clip, a 1-bolt connection. So let's see how we'll do this. I will first add the clip itself, and I will model it as a stiffening member. So I've added stiffening member, and I will change the cross section, and I will pick this CFL general shape of cross section. And now, of course, I will adjust these lengths and thickness, 4 millimeters, 4 millimeters, and the trick is here to set the angle as 0 degrees, and that shapes the clip itself. Whoops, I've got a message because I forgot I have a developer version of IDEA right now installed on my computer, so that's why I got it. But still, it works fine. It's just some message for the developers. However, let's continue with this. I will change the origin of the stiffening member. Now it's hiding inside the tube, and I want it on this plate. So let's change origin to plate number 3. And I'll position this a little bit more, set it as doubler. That means it goes along the surface. Change to rear, so that means it's now in between. And I'll shift it to the position I want, and that's like this. Last thing, just make it shorter, like this. Now it's pretty well shaped. I will turn off the welds here because I'm going to bolt it. And now I will connect the tube to this clip by using a cut operation. Select the tube, select the clip, the stiffening member, cutting method, surface, all fine. I'll set 3 millimeters of thickness, and I will shift this tube by 100 millimeters, so I don't have to cut it again. Just simply shift it. Now, of course, I will copy these 3 operations for the lower tube as well. So I will first shift it by this 100 millimeters as well. And now copy the clip like this. Here, whoops, this is okay. I will just mirror this clip by the Z-axis to rotate it and copy the cutting operation. Good. Last thing, bolt it. So let's pick the bolt grid operation. Again, developer message. That's not interesting for us. And we're bolting 3 items because the stiffening member consists of 2 plates, and one is half of a circle. And so I'm just going to pick, I have to switch to member, pick this, pick the plate, here switch to member as well, pick the lower plate of the clip. Fine, I'll leave the bolts like this and just position it. That means -20, -30 here, and all fine. Now, of course, copy and change the assigned plate. And that's it. So now we finished the design. I can turn on the forces and calculate. Now a minute or half a minute. Well, I can cut this time. I have it calculated here in an extra file. So let's see about the results. All is fine, green, gray. We passed the code checks. Design is quite okay. Everything well calculated. The good practice is to go to the check tab and turn on the mesh and deform shape, because the deformation, we can also turn on the stresses to get a better overview. And if I scale here the deformation by 80 times more than it is in reality, we can see the deformed shape and have a, let's say, a simple visual check if there's everything going all right or the way we would expect. So this is probably working well. This is very wild deformation, but if I go back to only 10 times, overscaling is just looking good. All right, well, that's it from the design part. And I will just, before I give presenter to Jana, I'll just show you where you can find the online project viewer, where you can export the joint to 3D DVG. You go to our website, ideastatica.com, go to cloud, project viewer, and here you can load the project and export it to the 3D DVG like this. Yep. So this is how it works, and then you can load it into Advanced Steel, Tekla, Bank. There are some limitations, but just try this out. It's a nice function. All right, thank you for your attention to my part, and now I'm giving presenter to Jana, and she'll tell you something about
Okay.
one customer problem.
Okay, so you should see my screen now. Yes, okay. Well, so during the last few minutes, I want to show you this project that we have received on our help desk, and the customer had a problem with cutting one end of this M1 member because he wanted to cut the edge to align it with the end of this plate and weld it. But as you can see, we have this warning that we cannot execute the cut operation. The reason is very simple. As this M1, if we select it in the right tree, you can see that this member is continuous, and that's the reason you cannot cut the continuous member. So if you want to have the member ended in the connection, you have to change the type of the member to end it. So let me just copy the project and we will correct it. So in the first on the first place, I will change the type to end it. Now I will also turn these two operations because I haven't mentioned it, but he wanted to cut it by working plane, but we don't need it anymore. I will turn it off, the cut and the working plane, and now I will just shift the member by 200 millimeters, but as the SP plate is connected to the member, I have to shift it as well. Okay, and you can see that it's solved. One more thing that should be corrected is or are the welds. They are not really visible around these corners, but you can always check the welds if you switch the view to transparent one. The welds are symbolized by this either yellow line or here yellow plane, and you can see that they are connecting the the vertical plate of this M1 member to the SP1 plate, and it's not very convenient solution because the weld is connecting something which is quite far from each other. So it would be better to connect, because you always have to select a plate that will be welded. So we will shift or change the weld so that it will connect the horizontal plate of the M1 member. I will select the weld and I will change the plate from Web1 to Web1, Web4 to Web1, I guess, yes. And now I have to switch the index of the edge to 2. And you can see that now the weld is much shorter, which is more correct. The same will be done with the opposite weld. I will shift it to Web1 of the plate and change the index to 4. Those indices are always visible in the transparent view. If you have the solid view, then you cannot sometimes see the index numbers. So I advise you to use the transparent view, and always you can also check whether the weld was or wasn't created. And I think we can just run the calculation and it should work. So it was not really a difficult case. It was just to know that if you want to end the member, you have to select the correct type. And here it is. So I think that's all from our content during the webinar. There were some questions, but it was very specific. There was no general questions, so I think we will just skip to back to the presentation. And as always, if you have been to our webinar sometimes before, also this time we ask you to fill in a short survey after the webinar. The recording of the webinar will be available during 2 days on our webpage under webinars, or also on our YouTube channel. There are many other videos, past webinars, some demonstrations. So it's quite interesting to go there and see what's there. If you want to try it on your own computer, get the trial version from our webpage. And if you have any question or you are curious how it works, so please go to our resource center. It's full of documentation to our software. We also invite you to the last webinar for the spring season, and it will be on June 19th. It will be focused on concrete this time, and our colleagues will present a pier cap design in IDEA StatiCa application focused on concrete. And if you ask when will be the next steel webinar, we will have a summer break, so we will see each other in September 4th, in another Connection Wednesdays. And till the time, we wish you to have a beautiful summer and see you after. Goodbye.
Goodbye.